Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to add speed brakes, split rudders, and deployable spoolers to our physics movement component. So as you can see here, I've got a new vehicle today. I'm going to be working with the B-2 bomber, and the reason why I picked this one is because, as you can see, it's got some unique characteristics. One, it's missing a tail rudder. So because it's missing a tail rudder, we have to turn the aircraft using what's referred to as split rudders. So a lot of these 6th generation aircraft which don't have the tail rudders are now now using this split rudder technology to help turn the aircraft. So as you can see, I've got the elevators and the ailerons, but when I use the split rudders, you can notice them because they're animated on the ends of the aircraft. Splitting out, and the whole idea is that it's there to create a spoiler effect or to disrupt the airflow evenly on the top and the bottom, so that the aircraft can then torque in the air space, as you can see here. So again, this is a flying wing, no horizontal stabilizer to straighten this out, so I've got to use all the flight control surfaces to kind of get this aircraft to fly the way I want it to fly. But it definitely creates a more unique flying experience when just using a flying wing. Alright, so that's the split rudder system, as you can see here, and we're just using the split rudders to turn the aircraft. We can turn left, we can turn right. And all it's doing is it's just creating a drag force at the wingtips, and then that drag force at position then goes ahead and creates a force, a counter force at point, which our system will then create a torque, which will then turn the aircraft the way we want. And so again, this is the split rudder system. But we can also do speed brakes and spoilers. So what I'm going to do is I'm just going to stop this simulation and set the default player to disabled. And let's see if we can go find our fighter. So this is our fighter jet, and this is going to use a spoiler system. And I'm just going to set this to player 0 and start back up. So now we're in the context of our fighter jet. So this is actually using a spoiler. Now I don't have the spoiler animated, but the spoiler on a Eurofighter is right behind the cockpit. And again, it's not, so it's forward of the center of gravity and up of the center of gravity. So let's get our aircraft in the air. So as you can see, I'm full afterburner. Well, I'm coming out of full afterburner. I want to bring it down a little bit. And let's go and make sure we've got some space across the lake bed here, so we can go and do a demonstration of what a spoiler will do on an aircraft versus a split rudder. So we've got the stabilizer, everything's looking good. So I'm going to deploy the air brake or the spoiler, and as you can see, what it's doing is it's actually pulling the aircraft up. So it's creating an imbalance of the airflow going over the aircraft. Or that's what we're simulating, which is going to then pull the aircraft up. So again, I'm going to hit the spoiler. As you can see, at high speeds, it's going to pull the aircraft up. So again, if you're in a dogfight, you could use your spoiler to kind of help with create high G maneuvering. But because, again, the spoilers and the split rudders are use the airflow, right, the density in the airflow, calculations, if we slow the aircraft down to a more reasonable speed, let me see if we can get this back over the lake bed again. Just gonna turn her around. So now if I hit the spoiler, as you can see, it's going to give me a more gentle braking. It is slowing me down, and as you can tell that by the fact that the plane suddenly wants to get closer to the camera again, so it's reducing the camera lag. And it's slowing the aircraft down because it's it's trying to pitch me up, and by pitching me up while I'm trying to go forward, we're actually then using more of the aircraft to the aircraft's wings to help slow the aircraft down. So it's helping to create a pitch. And as the aircraft gets slower and slower and slower, it's going to want to come down. And I'm going to go and put the brake back up. Once I put the brake back up, it's actually not going to help to pull my aircraft up. So by doing so, it's actually so if I leave that on too much, it's going to cause the aircraft to stall out. So that's what we have right there. So again, that's a spoiler. So the spoiler, all it does is it causes the aircraft to turn up, pitching the nose up so that the rest of the aircraft acts more like an air brake. Unlike the split rudders, which will open up now. And then again, the speed brakes, they're usually located on the center of gravity. If they get deployed, they're more set up for even use, and the whole idea of that will just create a drag, which will just slow the entire aircraft down without trying to do any kind of, changing the pitch angle or anything. All right, so that's what we're going to be building today. Good news is it's a single system, and I wanted to create a single system that can cover all three of these types of movement, and we can go ahead and it's fully configurable, and we can also use multiples and assign them to groups as well. So again, we can use we can handle split rudders as well as a single air brake system or a single spoiler system. So, as always, we have a lot of ground to cover today, so let's get started. Okay, so I've got Visual Studio up, and so this is our Physics Movement Live project, and so what we're going to do is we're going to go ahead and add this. We're going to first add the new system that we're creating, which is going to help us manage for all three of these types of drag components, and then we'll go ahead and then integrate that with the vehicle movement traits so that we can tie that in a bit more with the networking component, and then after that we'll then look to move into the vehicle simulation component and tie this all together so that we can then use it within our blueprints. So coming under simulation configuration, since this is where all of our systems are currently residing, so what I'm going to do is I'm going to come down and find the physics foil configuration, and I'm going to go ahead and add it right under the foil configuration, since it's all tied in with flight. And as you can see here, this is our buoyancy system if you've done the buoyancy. So I'm just going to put it above the buoyancy but below the foil configuration, and I'm just going to call this speed braking for now. Since that's kind of what I was originally building this for, before I started adding, making it a little bit more flexible. So I'm just going to go and copy this over and bring it over, and let's just make sure I've got this set right. So what we have here, so again, this is the physics speed brake configuration. I'm just going to go ahead and make this a little bit bigger for you guys so you can see what's going on. And let's just save it. So this is the physics speed brake configuration. So this, again, I'm just calling it this, but you can do speed brakes, spoilers, and split ruddering through the same. It's really a drag. It's a drag system for vehicles going through the air. So as always, we've got our tag name. And just in case we need to find, in gameplay, we need to find it to turn things on, set conditions. Something unique, I've got a speed brake group. So this is something that I pulled over from the buoyancy system, since we need, since we have one input that can be used between multiple different systems, we need to be able to keep things, keep the inputs together in the right order, so that those inputs are properly mapped. So when we set them on the GT, we can properly map them on the physics thread. So that's kind of what we're doing here for this speed brake group ID. The ability to turn it on or off. Area, again, since this is dealing with surface area hitting the wind, that's what we've got here. So that's our area variable, just like we do for control surfaces and foils. Force point. Everything that we do here has to have, we're adding a force at a specific location. So that's, again, this is using our reusable force location configuration struct. max control angle. So again, these are deployable. So yeah, they start off with 0, but then they can go to what is the maximum. So by default, I set this to 70, but again, we can change this later on in the blueprint depending on your aircraft and its needs. Right. So we have the longitudinal axis. This is our drag multiplier. So this is the amount of drag that is going to be applied as we are going forward into the wind on this component. And then we also have a lift multiplier. So I've set the drag multiplier to 1 because we always really want to have some type of drag, but you may or may not need a lift. So with the spoiler, I actually have a drag, but I also have a lift or a counter lift, which is really a downforce. So because when the way spoilers work is they create drag, but they also create downforce. So that's kind of what I'm doing there. But if I'm using a speed brake or a split rudder, then you probably don't need a lift multiplier. Actually, I don't use lift multipliers at all on the speed brakes because we want that applied evenly. Or have that drag applied evenly, so there's no real down or up force, there's just pure back. So again, so this allows us to create forces going in two directions, back and down, or up if it's positive. And since it's a lift multiplier, if it's positive it'll go up, if it's negative it'll create a down force. And again, we'll see that when we go into the blueprints when we configure it. Condition percentage, again, if you want to create a game with battle damage and these things can take damage, you can go and degrade their performance through the condition percentage, just like everything else. And then we have our internal index. Okay, that's right, yeah. So speed brake group, this is the group index. This allows us to group controls together. Yeah, this is my mistake. So this is what I'm using to group controls together, group these things together. So I can create as many of these as you want, and then you can group them together. So on the split rudder, I'm actually just using one on the left, one on the right. But if you really wanted to, you could try and mimic the top part of the rudder and the bottom part of the rudder. So then you'd have 2 on the left, 2 on the right. And again, you just assign them to their groups. And so that's how I'm controlling that. The speed brake index, this is taken from the buoyancy system. Again, it's allowing us to make sure that as we're putting the data in, we're keeping the data coming in from the GT in the same order as the data is being calculated and applied on the PT, the physics thread. So this just keeps things nicely even. Set brake position, we have set density of medium, and then we also have calculate dynamic pressure. So these are the functions that we'll be adding. Just 4 functions here, 3 functions public, and then 1 private function. And again, a lot of these are coming from the same systems that were used for flight control surfaces. And as far as private variables, we've got forward and up as far as the axes, so we need to know which direction we need to apply these forces. And then we have the density of current medium, control surface, attack angle, and then of course we've got the airflow. And again, we're setting that to an airflow of 0 vector. Forward axis is in the forward, up axis is in the up direction. All right, so now that we've got the structure in place, we need to go ahead and create these functions. So what I'm going to do is come over. So the first 2 functions here, set brake position and density medium, I've just inlined them, so they're right there. So again, this is the control surface angle. Then we do a clamp on the max control angle here. So we do a clamp on the input, which is the input coming in. So this is the amount of user input that I'm putting in. So for the split rudders, it's between 0 and 1. For the spoiler, it's either fully deployed or it's not. Well, that's how I've done it. So it's either going to be a 0 or 1. So this is the input, max control angle. That's going to be the control surface angle, which is the value that we're again going to be doing our calculations of. Density of current medium. Again, this data is coming from our environmental system. So again, if you're just using a single value, that's cool. That's air. But if you wanted to do air pressure on a curve, so air density pressure on a curve, you could do that too, depending on how you set that up. So that's, we're still using that. And then force, get force, we just need the velocity to be able to calculate the force. So this is the velocity that we're going in the forward direction, so we can get that, so we can calculate the amount of pushback that the drag system is going to be creating based on the speed that we're going into the air. And then again, calculate dynamic pressure. Again, it's taking velocity squared. All right, so let's go ahead and get these functions done. So all we need is, so these two are done in line. So let's go ahead and do the get force and then the calculate pressure. I think I'll probably do calculate pressure first, since that's, again, it's a function that we've seen over again. So where's foil configuration? I'm just going to put a little bit of space here, and I'm just going to bring this function over. So this function, we've seen this before. It's just taking the velocity squared current density, and then we just halve it. So there it is. That's the dynamic pressure. So then the next one is going to be our get force. So I'm just going to bring this one over. And so this is the get force function. So this is where all of that work on how we kind of be calculating the drag and down angle. So here we've got the force, 0 vector, enable force, and then we have the airflow magnitude squared. Again, if it's a really small number, it's, you know, we're not going to worry about it. There is no force. Getting our airflow and making sure that our airflow is going in the right direction. So airflow is based on the velocity that so the velocity, we're going in a positive direction, so we want the airflow to go in the opposite direction. And then we just normalize it. Then we can calculate the common, which is going to be the area of the surface that is going to be affected by the airflow. And then we're going to then calculate the dynamic pressure based on the airflow magnitude squared, which is what we've got here. That's going to go in, and the density and the pressure density. That should get us the area. And then what we're going to do here, so I'm going to create a lift coefficient and a drag coefficient. And then the way I'm going to do this is I'm actually going to apply the lift coefficient, or the drag coefficient is going to be applied on the forward axis, while the lift coefficient will be done on the up axis. And then, so here we're just going to be putting that into the force, and then I just do a concatenation here on the plus equals, so we're just adding this as an additional force to the force that we've already created up here. And then condition, all we're doing is force times condition. So if this is condition 1, we're okay. If this is degraded anywhere, but so as you know, then we'll bring back the degraded force and pass that back. All right, so that should do it for our simulated physics. That's all we need here for the system. So let's go ahead and go over to our vehicle movement traits so we can set it up, set this up for how we're going to manage the inputs. All right, so for the inputs, first thing I'm going to do is go ahead and set up, all we're going to do here is we're just going to be focusing on vehicle simulation input. We don't need to make any changes to the state object, we just need the input object. And again, this is going to be an input, but it's going to be an input on an array. So again, here's our array, double, I'm calling it speed brakes. As you can see, it's very similar to the way that the Sponson system works for water height. So instead of, this is the water heights, this is the speed brake value that we're going to be putting in there. And that's all I need to add there, but we also need to come over to our implementation code so we can update this. So first thing I'm going to do is I'm going to come down to the reset, and I'm going to go ahead and add a couple of resets in here. As I was kind of looking at the code for the Sponsons, I realized I didn't put a reset input there, so I'm just going to go ahead and add that here. So, but again, all we're going to do is we're just going to do a for loop on using I equals 0. We're just going to iterate through the values in here and set them to 0. We don't want to wipe them out, right? because if we destroy them, then there's nothing for us to put an input into. So all we want to do is we just want to go through this array that's already been, that we create on vehicle setup, and just zero out the values that are already there. And again, that's just there, and it's the same thing over here on Swanson height. So let's minimize that, but again, just doing the same thing. So that's the reset. So if we hit a reset button, which means we want to reset everything, it just then that we want to wipe out all of our, we want to reset all of the input values back to their defaults, which are going to be 0. All right, so next I am going to move up to the decay function. And again, back when I was doing the sponsons, I forgot. We did the interpolation, but we forgot the data decay. And so again, and the interpolation and data decay are used by the network physics movement component. So this is actually used by the physics movement component, the network components that we're using to send information up and down. And this is kind of how it's currently managing, you know, what happens if we start to get degradation between the client and the server. So we have the data decay. This is how much we want to decay the data over time if this value is not being updated quickly enough. And so again, just like we did for the XYZ in the yaw, pitch and roll, I'm doing the speed breaks. Again, this is just a lerp. And again, because, yeah, and we're just going to iterate through and just set the decay amount, and we're just going to decay that value by this function here. And I'm also just adding the, if you've done buoyancy, this is the part that I forgot to add. If you haven't done buoyancy, then you don't worry about it. If you do get to buoyancy, you just need to come back and add that back in. So I'm just going to go and minimize that. On the net serialization, again, let me see if I can find that real quick. I'm just going to go ahead and just put that in there. So it's just another thing that we're just going to, so this is just a bit operator. So we're just taking this and we're just squeezing this in. And then here we have the network physics. So this is the interpolation. And so for interpolation, I'm actually going to change this one a little bit just to kind of make it a little bit easier since we're adding more stuff in here. And we're probably going to have more of these inputs in arrays as we start getting into things like wheel setups for, wheeled vehicles. We'll need to go and set those up as well. So it's the same idea. So speed breaks, again, we're just like we did for decay, we're just going to iterate through, and this time we're just setting the minimum and the maximum interpolation values there. So that's what we're doing there. And again, I'm just doing this, I just updated the sponsons so they look the same way as the speed breaks. So all right, so again, I'm just going to minimize that one since we're not doing anything with water setup, only on. And I think that should do it. So again, this is for the network. So again, these where the reset is, again, it's kind of for the network, but it's also just to reset all the values in the physics. All right, so now that we've got the movement traits, and we've also got the as well as the system, right? Now we're ready to go into our vehicle simulation component and go ahead and add it in there. So we can then start adding that into our vehicle simulation. So, all right, well, let's get going on that. Okay, so now we're in the simulation component, and this is where all of our systems are. So I'm just going to come down to our surface, control surfaces, so I can kind of keep them all together. So again, we have buoyancy here, so I'm just going to move buoyancy down. And I'm just going to go ahead and bring over the simulation component for our speed brakes. And that's pretty much it. So again, it's an array, just like control surfaces, just like a lot of these things. This is an array. speed brake configuration, and that's pretty much all we need to do there. We do need to. I'm gonna add a function, some additional functions. So the first function I'm going to be adding is going to be to our update GT. So in buoyancy, we created this update buoyancy state here. GT, I'm going to do the same thing for the brakes. So there it is. I'm just going to add it. Just take this little video tag off, just a reminder what I need to bring over. So that's the update brakes. So we'll need that. And I think the only other new function that we need here is a way to set those values. So let me go find that code real quick. Here it is. So I'm just going to go ahead and put that. We'll put that here. Why not? So this is update. This is the set speed brakes. So this is the function where we're going to put the values in. And as you can see here, we have a value just like everything else. But I'm also going to use a group index. So it's a little bit like the set throttle input, but this is just an index ID, so we can decide which group we want to apply. So this allows us to say this value is going to be applied to this group of drag surfaces. And by doing so, we can then, again, this is how I got the aircraft, the B2, to kind of do a split rudder on the left and split rudder on the right, based on that value. So that's set the speed brakes. And then lastly, we need to have a raw input. So unlike buoyancy, where it's being calculated by the system, here again, this is a manual input going in. So, and because again, this is going to have a group component, I'm going to use a T-map or a map. So this is type map. So the int is going to be the group, the double is going to be the value, and this is going to be our speed brake input. So this is how I'm going to be managing those raw inputs, and it has some benefits to doing it this way versus just trying to put it into a raw array. So that's how we're going to do that there. All right, so now that we've got all of this, let's go ahead and get the implementation done. So I'm going to go ahead, let me just check my code real quick. Just want to make sure I've got everything here. We're not going to skip anything. All right, so yeah, I'm going to do that. Let's go ahead and just fix these green squigglies real quick. So that goes there. That green squiggly's it's okay. All right, so here we are. We're back in our code. So on begin play, I'm not going to make any changes here since so we have the create setup, right? This is fluid dynamics. This is our thrust. This is our control surfaces and our buoyancy. So because this is kind of a control surface, I'm going to go ahead and add it into our control surface setups here. So as you can see, we've got foils. We've got the these are the control surfaces. So I'm going to go ahead and add a third one in here. So I'm just going to open this up real quick. And this third one is going to be for our speed brakes. So here's our speed brake. There it is. And we're just going to iterate through. Now I'm going to hold an indexer here. And the reason why we want this indexer is because this is how, again, we're going to sync the inputs to the actual controls that we want to do. That way we can make sure that the right group gets assigned to the right set of controls between the game thread and the physics thread. All right, so again, first thing we want to do is we want to get the location, set our force point, so that's what's done there. Again, reusing a lot of code, which is always good. And then this is just how we're going to set the speed brake. And again, this is very similar to how we do it with the buoyancy system. So again, nothing too crazy. we're just going to take the index and set the internal speed break index. That way we know which order this is in, and we can maintain that order. And then what we're going to also do is on the simulation inputs, we're going to go ahead and add that into the array. So what we're going to do is we're actually going to create this set of inputs, and we want to create it so that it's there. We're setting it to 0 because it's going to be 0 unless we change it. So that's everything. That's all good. And again, just we want to make sure that we're just going to increment this so we get all these. So this order stays together. And I'm doing it this way. That way I don't. And by doing it this way, we don't have to have a loop within a loop and try and look for something. Instead, we're just going to say this array, all the arrays that we have for SpeedBreak are in the same order, and we're going to trust that order because we're going to go ahead and set it that way. So without this, we'd have to have a loop within a loop, which can be a lot more costly than just doing a straight single loop. All right, so that should do it for that. Next, let's come to our new function. So this is the update speed breaks GT, and I'm just going to go copy this over from the other one. All right, so interpolate. We need to add something here, which is the interpolated value for getting our interpolated values on the speed breaks. So not to worry. So we just need to add. So just like we did for all of our other controls, I need to come back to our components, and we need to add. So here we have the throttle configuration, throttle rate input. We just need to do the same thing for our speed brakes. So I'm just going to go find that. Here it is, speed brake. And I'm just going to add that here. So again, just reusing this construct. Again, just reusing structures. Reuse is good. So that's what we're missing here. So this is vehicle inputs. So this is just how we're able to kind of create some interpolation on the inputs to kind of give us that weighted feel within the control. So we come back, there it is, and that's okay. So again, nothing crazy here. Again, full code reuse, but this one's now set for speed brakes. So again, we're iterating through the control. Now we've got the brake ID, which was actually, this is the speed brake ID. So this is the group ID that we're looking for. So what's happening here is that this is the raw speed brake input. This is our T-map, right? And we're going to be putting things in based on the index. Actually, you know what? Let's go ahead and just do that real quick before we do anything else. So it'll be a little bit easier to kind of understand. So I'm just going to do this here. Okay, so this is the speed brakes. So this is the input coming in. So because I wanted to be able to manage both analog and digital, right? So digital is 0 and 1. Analog you can either be, or an axis value can either be -1 or +1. But again, everything needs to boil down to between 0 and 1. So all I'm doing here is taking the value, getting the absolute value of it, and then we'll clamp the value the absolute value between 0 and 1. So it's always going to be positive within the system. The only reason why we have negative and positive is because we just, it's just if we're using an axis, the left side's going to be on one, the right side's going to be on the other. It just makes it a bit easier. And then this is our map, right? So again, the group ID and then the value. So then if we come back up here, we don't need buoyant forces, so I can just close that. And we'll come back up to control surfaces. So what we're doing, actually, no, we don't need this anymore. We're here. Speed brakes. So again, what we're doing here is we're just going to go in on the update state, right? We're going to say on the GT, we're going to go and do a find, and we're going to do a find by reference. So there's two ways to do a find on here. So there's find, but what this is going to do is it's going to return a pointer. So this will find it, return the pointer, and then you could say, okay, if the pointer is valid, that means it found something. If the pointer is not valid, it didn't find anything. But if you do a find by reference, it's actually going to bring back the value. So it kind of does that internal check for us. Now, the nice thing about the find by reference, and the reason why I'm using is because one, it's going to bring me back the value regardless. So if it finds something, it will bring back the value. If it finds nothing, it's actually going to bring back the default, which will be 0, which is exactly what we want. So it's either we want the value, if it finds it. If it doesn't find it based on that group ID, then we just want 0 because we want to 0 it out. So this does find by ref does exactly what we want. So that's why we're going to use that. So again, it'll either bring back the value or it'll bring back the default. So once we found it, then all we're going to do is we're just going to run that value through our get interpolated value on the speed brake, and again, that's a setup that we'll also set up when we get to the blueprint. And then I've got a little error message here to let me know what that value is when I turn debugging on. So, and this can be useful to see which group has which value. And then once everything is done, once we've finished this, then all I'm going to do is, again, we're going to consume that input and reset it ready for the next input that's going to come in. So that's all we do here, and we just need to make sure we do this. That way, the raw inputs are always going to be the most up to date. We don't want to keep any dirty data there. But when it comes to speed braking, right, and that's the reason why we split the raw inputs from the inputs that we're using, is because if the physics thread is going to be running faster than the game thread, right, and if the physics thread's running a lot faster than the game thread, then we need to keep those physics inputs still valid until the game thread changes the input. So again, this is how we're managing the state between the inputs between two threads. All right, so again, speed brakes, reset, consume the input, and so that we can ready for the next input coming in. And this is going to happen on the game thread. All right, so that is everything for our update GT. So what I'm going to do is I'm just going to come down to the game tick, right? And I'm just going to go ahead and add that GT here. So again, I'm just going to grab it and I'm just going to put it in there. So this is the update GT. So tick is happening on the game thread. So that's what we want there. And so here it is, everything's happening, and so I'm just going to add these speed brakes. So we're going to update the inputs from what we originally created. We're going to update any inputs from speed brakes, and then if you're using any buoyancy, so if you're building seaplanes and you want the plane floating on the surface, we'd then update that too. All right, so we've got that. We've got the speed brakes. I'm just going to minimize this, and we'll minimize that. So next is going to be applying the inputs. So as you can see here, we've got our thruster setup. We've got our gimbal thrust. We've got our control surfaces here. So what I'm going to do is underneath the control surfaces, and we've also got our buoyancy. So underneath the control surfaces and above buoyancy, I'm just going to go ahead and add the speed brakes. So this is our speed brakes. So this is, again, now this is where we're using the braking index, right? So this index ensures that we don't have, that we're saying that this object here, this array and this array are both in synchronization. So as we're going through the speed breaks, right, we can then go ahead and say, go find me the value which is mapped into the simulation input right here. So this is taking and this is then going to go ahead and take the speed break input and set the break position here. And so this is the input coming in. This will set, the amount of surface that's going to be put into the airstream to create that drag effect. All right, so that's it. That's that for inputs. And again, this is happening on the physics thread now. And next I'm going to come down to, okay, update simulation. We don't need to do anything there. I'm going to come down to apply control surface forces. And so this is where we're applying the control surface forces for our, for the flight control surfaces. And what I'm going to do is I'm just going to add an extra, I'm just going to piggyback off this function here for our speed breaks. And I'm just going to go add that in there. So we've applied the input. Once the inputs are done, then we're going to come down and then we're going to apply the forces. So based on those inputs. So this is for the control surfaces. I'm just going to go and minimize that. So this is for the brakes. So again, we're going to go ahead and set the density. Again, this density is coming from our fluid dynamics system. Right, so there it is. Based, and if we have an altitude, we've got an altitude. Otherwise, if we don't need to worry about it. Right, center of mass. Again, this is useful because everything has to be done based on the center of mass of the aircraft or the craft. Speed brakes. So here's our SB speed brake configuration. So first, we're going to set the density of the medium that we're traveling through, so we can calculate based on the density. Then we're going to get the world location of our vehicle. No, we're going to get the world location of our force point. So that's what this is. So again, we're going to go into the simulation transform. So this is the position of our vehicle, simulation state, world transform. That's the vehicle and where the vehicle is in the world. And we want to know where the force of that is in the world. So again, that's based off the center of mass and the location. Then we've got the velocity. So this is the local velocity, and we're going to inverse that and get the world velocity points, passing in the handle and the local. So that's the velocity local. And again, this is all reusing functions that we already created. And again, just like the other one, but this time we're going to be using the SB version of get force, which is going to take the local, and we've got some calculations here to go and convert it from centimeters to meters, the velocity. And then we have the simulation state will transform velocity. So again, so what this is doing is this is calculating the force. But then what we need to do is we need to then rotate the force into the direction that we want that force to be applied in. So as the vehicle's moving, right, its transform is changing, its rotation is changing. So we need to make sure that when we apply that force along the XY, we have to rotate it so that it's being applied in the same direction as our vehicle. So that's what that's doing. And then once we've got the world force, we're going to go ahead and add that. So this is the world force. So this is the force that we want to place in the world, and this is the location that we want to place that force. And this is force at position. So again, we're going to be creating a force and a torque based on where we are in relationship to the center of gravity or the physics particle. All right, so that should be it for applying the control surface. Let's see. Is there what else do we need? Restart simulation. Do I have that? Reset simulation. Yep, there it is right here. So I'm just going to add one more thing to simulation inputs to reset the simulation, and it's just going to be making sure that we... So what this does is it's going to clear the inputs on the GT, so we need to clear this, and then it's going to clear the inputs on the inputs going to the physics thread. And that's all that does on reset. Alright, so that should do it for everything that we need in the components. So again, we added the speed brakes here, so this is the configuration. We've also added the speed brake input rate configuration, so this again allows us to do some interpolation values on that input coming in off the controller. And then we went ahead and piggybacked on the create control surfaces. So again, we went ahead and created that control surface within the array, making sure that we've got the speed brake index, which is what we're using as an internal way to keep the input array and the system lined up. And we created our new update GT. So again, this is as the game thread updates, we're taking the input and applying it to the simulation input so that it can be passed on to the physics thread. We updated the apply inputs, so as we're iterating through the input based on the speed brake index, so this is the internal index value to make sure that this array and this array are lined up. So that is getting the input variable and applying it to the speed brake. And then once the inputs are set, then we're going to apply the control surfaces, and this is again, this is all now happening in the physics thread. So as we're applying it for the for the ailerons and elevators and everything in here, we're also going to apply it here too in this for loop. And again, at position, just like that one's at position. Again, there's a lot of reuse in here, which is good. And then we're going to come down. We created our new set speed brake function. Again, value and index group. So that's what we have here. And then a way to reset if we need to reset. So it just clears out all the values. And then on the tick component, so this is our physics thread. This is our game thread running. We just made sure that we are updating this information before we, so that the physics thread can then use it the next time the physics thread ticks. All right, so I think that should do it for this video. In the next video, I'm going to go ahead and we'll make sure that we'll compile it, make sure that everything's good, and then we'll go into the editor. We'll go ahead and add the spoiler to the Eurofighter, and then after that we'll bring in the B2 and set that up so that we can fly that plane as well. Alright, so as always, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel. If you have any comments, feel free to leave them below, and I'll see you again in the next video. Cheers, and have a great day.